Imagine a world where we weren't surrounded by air. Without the oxygen in the air that we breathe, we wouldn't survive very long. But what about animals underwater? They need oxygen too. Where do they get it? The answer is from the water, because water actually also contains dissolved oxygen. Dissolved oxygen is just what it sounds like. It's oxygen that's dissolved in water. But what does it mean for something to dissolve? If you've ever mixed sugar and water, you've noticed that the sugar seems to disappear. But what really happens is that the molecules of water mix with and surround the sugar molecules, breaking up the large sugar granules to make a sugar-water mixture. More specifically, since the parts of the mixture are spread out equally and evenly everywhere, we can call this mixture a solution. So when we say that something dissolves, it just means that it goes into an evenly distributed mixture called a solution. Now, like those sugar molecules, oxygen molecules also mix evenly with water molecules to form a solution. In other words, oxygen dissolves in water. But how does the oxygen get there in the first place? Well, there are two main ways that oxygen can enter a body of water, like the ocean or a lake. One way is from the atmosphere, or the air around us. Oxygen makes up about a fifth of the atmosphere, and these oxygen molecules are constantly bumping into and entering water. Even more oxygen enters water through photosynthesis. You probably know photosynthesis mainly as the way that plants around us feed themselves. But there's actually a whole slew of other photosynthetic living things aside from plants. From tiny green bacteria called cyanobacteria to little phytoplankton with crazy names like dinoflagellate and even crazier bodies. All these creatures can produce food through photosynthesis. But in doing so, they actually also produce oxygen, which then dissolves in the water. What happens to this dissolved oxygen? Remember that like us other living things, the animals, plants, phytoplankton, and bacteria living underwater also take up oxygen to live. Furthermore, oxygen molecules are continually shuttling back and forth between the atmosphere and the water. But note that there's always at least some amount of oxygen that stays dissolved, and this amount depends on water conditions like the saltiness and temperature of water and how much dissolved oxygen there is compared to the oxygen levels in the air. Now, why does the amount of oxygen already dissolved in the water and the surrounding air matter? Well, it's the same principle as walking into a crowded room from an empty hallway. You don't want to go in, and the people inside are trying to get out. In the same way, if there's more oxygen in the water than in the surrounding air, then the oxygen moves to the roomier atmosphere. Or if there's more oxygen in the air, then the oxygen moves to the water. The principle is the same for the saltiness of water. If you've ever tasted seawater, you know how salty it is, and that's because there's salt dissolved in seawater. Well, those salts are also taking up space in the water. You can imagine that as adding even more people to your crowded room, and the more people there are, the less room there is for you. So the saltier it is, the less space there is for dissolved oxygen. What about temperature? Well, when things heat up, they start moving around. Imagine yourself in a crowded room again. As everyone starts jostling around, it's a lot easier to move out of the room. Again, it's the same for dissolved oxygen. The oxygen molecules warm up and they start vibrating, making it easier for them to escape the water. So let's sum that up. Dissolved oxygen enters water from the atmosphere and from photosynthesis, and then gets taken up by living things or exits into the atmosphere depending on water temperature, saltiness, and the amount of already dissolved oxygen. Now you're probably thinking, who cares what the amount of dissolved oxygen is? Well, remember that living things need oxygen to live, and the more oxygen there is, the more animals can live there. So scientists measure dissolved oxygen to find out how healthy a body of water like a lake or a river is. But animals also adapt to the amount of dissolved oxygen. Fish like salmon need a lot of oxygen so they can only live in colder places, but fish like catfish can live in warmer waters because they need less oxygen. If you've ever wondered why the kinds of fish are different in different places, this is one reason why. Unfortunately, even these fish die off at very low oxygen levels, and humans have been decreasing freshwater oxygen levels in a process called eutrophication. Eutrophication is a big word that just means adding a lot of nutrients good for growing, like nitrogen and phosphorus, to a lake or a river, usually by pollution. That causes a lot of plants and cyanobacteria to bloom. Aren't plants good though? Don't they produce dissolved oxygen? Well, yes, but when they die, they sink to the bottom of the lake and decay there, and this decay uses up all the oxygen in the lake. With no oxygen to breathe, the fish and other animals die and the lake becomes unhealthy. So throw your trash properly and recycle. Together we can preserve our marine and freshwater ecosystems.